All right, so I'm going to talk to you a little bit and hopefully clear some things up about factoring. And as I go through this, feel free to pause, rewind, or do whatever you need to do to make your way through the lesson, okay? Now, if you don't need any of these extra examples, you can fast forward through, you can rewind, use it as you need it, okay? Now, just as a recap, when we factor, what we're doing is we are doing the opposite of distributing. So maybe, let's see, if I had these two binomials, if I multiplied these, I would start by distributing this first term to everything in this parentheses, so I would have 2x squared minus 10x plus 3x minus 15, right? I took this term and distributed to everything, and then I took this term and distributed to everything. So what now I do is combine my like terms here, negative 10x and 3x, and I know I'm kind of running through this fast because this is an old skill set, right? This is something we learned how to do a long time ago. But what factoring does, so this way is multiplying, okay? What I'm going to do now is I'm going to go from this bottom one up to this one. So I'm going to have two binomials multiplied together. Binomial meaning two pieces, okay? So this is factoring. Now, factoring can come in many forms. We can have basic factoring, or we can have some pretty difficult factoring. So basic factoring is really taking out a greatest common factor. So you need to know what greatest common factor is, right? We talked about this a little bit, but just as a recap, a greatest common factor is going to be the biggest thing that you can divide everything by with no remainder. So if I had 15x squared plus 35x, okay, the greatest common factor of these two would be, I look at the numbers in front, I could divide them both by 5, right? 5, and they both have x's. This one has 2, this one has 1. So what they have in common there would be 1x, right? So when we take that out, what it's going to look like is I put the GCF on the outside, and in parentheses, I write what's left. So 15 divided by 5 would be 3. Take one of those x's away, it leaves me with 3x. And then 35 divided by 5 would be 7, and I took the 1x away. What your goal is that if you distribute back through, you end up with what you started with, right? This is the backwards of distributing, and if you keep that in mind, it really helps concrete the concepts here. All right, so let's talk about factoring then just a little bit. We're going to have a quadratic. Let's say x squared, we'll start easy, plus 9x plus 20, okay? And remember what it is we're going to do. We're going to take it from looking this way to looking this way, okay? All right, so here's what we do. List out your a, your b, and your c, okay? Remember, these are coefficients. We're not talking about with the x, we're talking about the coefficients in front. So remember, it's ax squared plus bx plus c, okay? So here a equals 1, b equals 9, and c equals 20, okay? So when we multiply a times c together, we get 20, right? Here's the puzzle part, as I like to call it, of factoring, all right? And if this is, to me, the hardest part, and this is a slightly easier one, we'll get to some more difficult ones, but if you can get this part down, you shouldn't have any trouble with the rest, because to me, the hardest part is figuring out this puzzle. So here it is. What two numbers do you know of that when you multiply them together, they give you 20 from here, but yet when you add them together, they give you b, okay, whatever this b is, they give you 9, right? So, I'm looking at this going, I I don't know. Let's list out some factors of 20. What all can you multiply together to get 20? Well, I could do 20 and 1. I could do 10 and 2. I could do 5 and 4. I could hold the phone. Look at here. 5 and 4. 5 times 4 gives you 20, and 5 plus 4 is 9. Okay, so there it is. The better you get with this, the more practice you do. You won't have to list them all out here. You may not have to list this over here. You'll start to pick up on these factors fairly quickly. Okay, so what I'm going to do is I am going to rewrite this middle term as 5x plus 4x. Okay, so now I have x squared plus, and the order does not matter here. Okay, if you put 4x and 5x and I put 5x and 4x, it does not matter. You're going to come back to the same thing. Alright, so what I want you to do is look at this as two separate problems. First thing, look at these two terms. Can you take a GCF out? Remember, GCF means greatest common factor out of these first two terms. And I hope you said yes. And I hope that you see that what they have in common is actually just an x, right? So if you take out the x, factor out an x, what's left? Well, if I take an x away from here, it leaves me with an x. And if I take away an x from here, it leaves me with a 5. Remember, if you distribute it back through, you want to come back to what you started with, okay? Very important, this middle sign always stays. It does not matter if it is a plus or a minus, it is going to stay, okay? Now look at the last two. The greatest common factor of 4x and 20, so what goes into 4x and 20 both? And I will tell you right now, if you get to one that does not have a GCF, one is always a GCF, okay? Alright, but in this case it does, and it's 4. So if you take a 4 out of both of these, it leaves you with an x plus 5. Again, if I redistribute, do I end up with what I started with? And the answer there is yes. So now, if you look, this factor x plus 5 is repeated. Okay, so in the same way that I take an x out, I'm going to take out an x plus 5. Okay, because both of these terms have an x plus 5. So I'm just going to take that out. I'm going to take it out and put it out front. And once I take it away from both of them, what is left? I have an x and I have a plus 4. And my equation, or my expression, is factored. Okay, I have gone the backwards. If I multiply that out, I will end back up here. Okay, one important thing that I failed to mention in the very beginning is before you factor, always look for a GCF. And I'm just going to write this on here, so if you're taking notes, make sure this is in your notes. But always look for a GCF before you start factoring. Okay, that's very important because it's going to help your answer be simplified. Now, it's not that it won't factor. As you factor by grouping here, it will still factor. Everything will be okay. You'll just have some simplification to do in the end. So it's better to do it in the beginning than at the end, okay? All right, let's look at another example. Maybe one with a little bit different signs here. Let's say I have 6x squared minus 23x, and here you see I got a minus, we haven't done one of those, plus 20. Okay, so I'm looking overall, is there a GCF that I can take out of everything? And the answer to that is no. I can't. There's nothing that I could divide everything by without a remainder. So what I'm going to do is move on to listing out my A, my B, and my C. Okay, so here A is 6, B is negative 23, and C is 20. Okay, multiply A and C together to get 120. So I'm looking for two numbers that are going to multiply to 120, but when I add them, I get negative 23. Okay, and here's where you have to kind of think, If I'm multiplying to a positive number but adding to a negative number, that gives me a clue to my two numbers already, and it tells me that both of my numbers are going to be negative before I even begin, right? Whatever it is, the only way to get a positive when multiplied but a negative when adding is if they're both negative to start with. So I'm looking for two negative numbers as I go through this. Now, things that multiply to 120. Remember that both of them need to be negative. So maybe, let's see, negative 12, negative 10. Does that work? Well, multiplying it works, but when you add, you get negative 22, and that is not negative 23. Okay. How about, what else goes into here? 15 maybe? 15 and negative 8. There we go. Okay, those are the two factors. And maybe you don't find them that fast, and that is okay. It's going to take you a while as you get used to this, all right? So my two factors here are negative 15 and negative 8. When you add them together, you get negative 23. Multiplied gives you 120. So this is what I'm splitting my middle term up using, right? I've got 6x squared minus 15x minus 8x plus 20. Again, look at this as two separate problems, okay? What is the GCF of 6x squared and 15x? If you said 3x, you are correct. It leaves me with 2x minus 5. Okay? Very important. Remember that middle sign? It stays the same regardless. It doesn't matter. It has to stay the same, okay? GCF of these two is 4. Now here's where things get a little bit confusing sometimes. You're really taking out a negative 4. Remember, when you distribute this back out, it's got to look like this one. So when I do this, when I take this GCF out, I'm left with 2x here, but I need to make sure this is negative 5 so that whenever I distribute negative 4 back through, I get a positive back out, okay? So in general, if your middle sign is minus, it's going to force that last sign to change, okay? So if it started out positive, like this one did, it's going to turn negative, and if it starts out negative, it's going to turn positive. It's going to change that sign, okay? Now again, here's my repeat factor of 2x minus 5. And it leaves me with 3x minus 4. Easy peasy, I hope, at least, okay? There's, of course, a little bit more to it. We got through all of this part in class, so hopefully that just kind of concreted some things in for you. Everything cannot be factored. Sometimes you will run into some things that can't be factored. That's okay. And sometimes things are a super, super easy factor. Sometimes all you can do is take out a GCF, and that's it, okay? So maybe something like 16x squared plus 8x. The only thing you can do here is to take a GCF out if I'm asked a factor of 8x, and it leaves me with 2x plus 1. Okay? Nothing else I can do with that. That's it. All right. So the bigger question here is, why in the world, Miss McGee, do we factor? What is the point in factoring? I know I can do it. I see you do it. I can probably do it myself with enough practice, but why are we doing it? And that is an excellent question that I am so glad you asked. The reason that we factor is to help us to solve these quadratics, okay? I want you to think about something with me for just a minute. If you have two things, again, we talked about this today in class, but if you have two things that multiply together to give you 0, and I'm not telling you what they are, I'm just saying I have something times something, right? The only way to get 0 when you multiply something times something is if one of those somethings or both of those somethings are 0. So this has got to be 0, or this has got to be 0, or both of them are 0. But if I let either one of them be 0, it's going to make my equation true. So this is called the zero product property, and it's what we use when we factor to solve, okay? And I hope this comes full circle for you in just a minute when you see it with the graphically, okay? So maybe I have this equation of, let's say, x squared minus 11x plus 30 equals 0, and I say, you know what? I don't have any earthly idea how to solve that unless I know that I could graph it, right? I could graph it and I could see where it crosses the x-axis, and those would be my solutions. I know I could do that. But algebraically, So here's where we're going to use factoring, okay? So the first thing we're going to do is we're going to make sure it equals 0 if it doesn't already, and in this case it does, right? And then what I want to do is I want to factor, if I can. And in this case, excuse me, I can. Alright, so A, B, and C. A is 1, B is negative 11. I'm going to write over my little sketch of a parabola here. So I'm looking for two numbers that multiply to 30 but add to negative 11. Here I go again. It's got to multiply to a positive but add to a negative. So both are going to be negative. I'm just going to start listing some out here. I'm not real sure what they are, but I'll find them eventually, right? Negative 3 and negative 10, negative 2, negative 15, negative 30, negative 1, negative 5, negative 6. Hold up, wait a minute. There it is. Okay, there's my two factors. So I'm going to rewrite. Okay, and now I'm going to go through. What is my GCF? So you said x, excellent work. Leaves me with x minus 5. Remember, keep that middle sign. Greatest common factor of 6x and 30 would be 6, and it leaves me with x. Remember, this sign is changing because of that middle sign. It still equals 0. I haven't done anything with that side. Factored, the x minus 5 comes out and leaves me with x minus 6. And now here, take a look at this. I have two things being multiplied together to give me 0. Well, one of them or both of them must be 0, right? So set each one to 0. I'm going to say set each factor to 0 and solve. Add 5 to both sides, add 6 to both sides. So actually this parabola that I sketched, my A is positive. I've got a 1, right? So it's opening up. This is 5 and this is 6. It's crossing the x-axis at 5 and at 6. Okay? Hope that makes a little bit of sense for you. Let's do a couple more and see how you do with it. Okay? Some of them may look a little bit different, and these are actually, students will generally struggle with this, and this is a little bit of an easier factor. If I had 21x squared minus 14x equals 0, and your directions just said to solve the equation, okay? So remember, when I factor, what I first want to do is look for that GCF, and in this case, I do have a GCF. I have a GCF of 7x. And it leaves me with 3x minus 2. Now, I can't factor this any further. This is factored completely, right? I mean, there's no more squareds in here to factor. So what I can do, I still have something times something to give me 0. So set those somethings equal to 0. Well, 7x equals 0. 3x minus 2 equals 0. Okay. Divide by 7. I know that x equals 0. I can add 2 and divide by 3. So x equals 2/3. So whatever else this parabola is doing, and you see the c is 0, so my y-intercept is 0. I can learn a lot from it right now. The y-intercept is 0. It's crossing at 0. and at 2/3, if this is 1, it's crossing at 2/3, and it's opening up, right? So even if I don't do anything else, I know that. I know that my zeros are 2/3 and 0 itself, right? Okay, hope that helps a little bit. Now, there are some special patterns that we will get into, and I'll just go over them really quickly because I want you to be familiar with them for a couple of reasons. The first pattern is what we call a difference of two squares. Now, you can factor this the exact same way that we have been doing with grouping, okay? But if you happen to see it, it's a quick and easy factor to be able to apply this pattern and move on from there, so you really don't have to go through all the trouble, and you'll find that very convenient as we move forward. So difference of two squares says if you have two perfect squares separated by a minus sign, because that's what difference means, right? Difference means, hey, subtract. So do you think this works whenever you have a plus in the middle? No, only when you have a minus, because it is the difference of two squares. But if that happens and they are both perfect squares, it is a super duper easy factor. You do the square root of the first one minus the square root of the second one times, and then you do the same thing but with a plus. Okay, every single time. So for example, let's say I have x squared minus 25. These are both perfect squares, yes? X squared 25, it sure is. So to factor it, x minus 5, x plus 5. Okay, easy peasy. Now, just because y'all know how I am going to show you that it's the same thing if I group it, okay? I am missing the b in the middle, so I am going to hold the place with a 0. A is 1, B is 0, C is negative 25, and I'm going to multiply A times C. What multiplies to negative 25 but adds to 0? It is 5 and negative 5. So I'm going to, instead of 0x, I'm going to write that as positive 5, negative 5, right? Because that makes 0x anyway. GCF here would be x, and it would leave me with x plus 5. Keep that middle sign. GCF here would be 5. Again, because it's minus, change that last sign. And look, leaves me with x minus 5. Okay? Quick and easy. Difference of two squares. Now the other pattern, and this one is going to be important for you to remember for what we're going to do next for our next lesson. This next one is called a perfect square trinomial. Okay, it is just a pattern and it is making for an easy factor, but I'm going to need you to be able to do this for what we're getting ready to do next. Okay, perfect square trinomial has 3 criteria that it has to meet. Trinomial means 3 pieces, right? It also has 3 criteria. The ends, remember I told you 3 pieces. The ends have to be perfect squares. That's criteria number 1. Okay. The second thing is that the second sign has to be a plus. This sign must be plus. Now notice I didn't say anything about this sign. The second sign has to be plus. The third thing is the most difficult thing to see. Okay, the middle term has to be double the product of the square roots of the ends. And you say, whoa, Miss McGee, what in the world are you talking about? If you I'm going to write double product square roots of the ends. And that is a mouthful, okay? And what that's saying is if you take the square root of this one, so that would be A, and you take the square root of this one, that would be b. Product means multiply them together, double. Okay? If you meet all three of those criteria, you have a perfect square trinomial. Now this first sign could be a plus or a minus. All right? If that's true, then to factor it, you do the square root of the first one. You take whatever sign is here, okay? And then you do the square root of the last, and you put a squared right here. Okay? I know that's a lot to look at, so let me show you an example. If I have, let's say, 4x squared, minus 44x plus 121, okay? And I want to know, is that a perfect square trinomial? Well, are the ends perfect squares? Why, yes. Yes, they are. The square root of 4x squared is 2x. The square root of 121 is 11. Is the second sign positive? Well, it absolutely is. If I take the square roots of the ends, multiply them together, and double it, does that give me what's in the middle? Well, let's see. The square root of 4x squared is 2x. The square root of 121 is 11. If I multiply those two things together, that gives me 22x. Doubled, well, it sure does. It gives me what's in the middle. So that means to factor it, it's 2x, the very first sign, and 11 squared. It's an easy factor, okay? I know that this is a lot. I want you to really try with this and see how you do with the factoring, okay? Again, we're going to do a lot that are for solving, okay, and relating back to the zeros themselves. Let me just show you, if I have, and I want you to think about this for just a second, going back to one of those examples in the beginning I had, when we were talking about the roots, right, and the zeros, we had x squared minus 11x plus 30, and we found 5 and 6 were the roots, right? If you know the roots, you can write an equation also, because look, if 5 is a root, then x minus 5 must be a factor. And if 6 is a root, then x minus 6 is a factor. So if I have the zeros or the roots, then I also have the factors that multiply together, okay? So just quickly let me show you. If I said that an equation or a quadratic had the roots, and this is actually number 1 on your homework, -8 and 5 are roots, and they want you to write a quadratic in standard form with the given roots, okay? Well, the first thing that I know is that if this is a root, then x plus 8 times x minus 5 are the factors, right? Now it asked in standard form, so what I want to do is multiply this out. So x squared minus 5x plus 8x minus 40. So in standard form, I have x squared plus 3x minus 40. Big connection here, though, is that I want you to see that when I have these two values like this, essentially I have my zeros. X equals -8 and x equals 5. These are both zeros of the functions. I've just had to change the sign, right? And I had to change the sign because I had to say, well, when x plus 8 equals 0, subtract 8 and you get -8. Okay, so the opposite signs there, those are my zeros. Okay, I think you have enough information now that you can get on your factoring. Try your very, very best. One more hint before I set you loose. That is, if you ever see a negative leading coefficient, okay? Leading coefficient meaning the number in front. Always try to factor that out before you start factoring. So maybe I have something like negative 8x squared plus 46x minus 30 equals 0. And I'm asked to find the zeros of the function or solve the equation here, okay? The very first thing I want to do is I want to look, and by the way, this is number 43 on your homework. I want to look to see, is there anything that I can take out as a GCF from all three of those pieces, right? And so as I look, I don't think there is, but what I do want to do before I start factoring is I really want to take a negative 1 out, change the signs of everything here, and then factor this from there, okay? So A times C would be 240. So I need two numbers that multiply 240 but add to negative 46. And I'll let you finish working on this one to figure out. But what? All right, I guess I'll go ahead since I've already started this one. If you keep plugging numbers, 24 and 10 doesn't work. Keep going, keep going, keep going. 6 and 40 would work, both of them being negative. Okay, so I'd have negative 1, 8x squared minus 6x minus 40x plus 30 equals 0. GCF here would be 2x, and it would leave me with 4x minus 3. Keep that middle sign. I can take out 10, and it would leave me with 4x, change that last sign, equals 0. Okay, and I can already see, and I'm glad I did this so that you could see, these did have a GCF. Notice I could have divided everything by 2 before I started. I would have made my life so much easier if I had done that. But of course, being Friday afternoon at the end of the day, I didn't. But that's okay, because this is a good thing for me to do to show you. As I factor this, the 4x minus 3 comes out, and I have 2x minus 10. Now here's where I knew, because whenever I got to this point, I said, wait, both of those are divisible by 2. I could have taken a 2 out. But this is good because you see it still didn't mess up. A lot of factoring techniques that you use, if you miss that GCF in the beginning, you've messed up the whole problem. But in this technique, it's really good because you actually haven't messed anything up. And so I could rewrite it. I could take that 2 out now and change that negative 1 to negative 2. And take that 2 out and have x minus 10. X minus 5, excuse me. Or I could leave it like that, okay? But at the end of the day, I'm still going to solve. I'm going to get the same answers. I'm going to say 4x minus 3 equals 0. I'm going to say x minus 5 equals 0, or 2x minus 10 equals 0. I'm going to add 3 and divide by 4. And I'm going to add 5 for my two answers. Okay? I think you should be good to go. I hope you guys have a great weekend. I will see you Monday. We will go over this some more. If you have any questions, let me know. See you guys.